Hi there, it's Jason Gorman from Codemanship, confined to base for the duration, with the first in a series of videos on test-driven development in Java. So if you've been watching my YouTube channel, you may have noticed that I've already done 3 versions of this in JavaScript, Python and C#. We get to Java last. There's going to be 7 videos covering 6 particular topics, and this first topic we're just going to look at the basic process of test-driven development, the 3 steps of the TDD cycle. Test-driven development, as the name implies, means driving the design and development of our code using tests as specifications. So the process goes like this. We start by writing a test that fails, which describes something we want our code to do that it currently doesn't. And then we write the simplest thing we can think of to get that test passing, to the simplest, quickest thing that comes into our minds. So we write a failing test and we write the simplest code to pass the test. And then, if necessary, we refactor the code so that going forward the code is going to be as easy to change as possible. So we look for problems like code that is difficult to understand. We look for problems with complexity or with duplication or with dependencies or anything else that we think going forward is going to make this code harder to change. And it's the refactoring step where a lot of the design in TDD actually happens, as you'll see in subsequent videos. But to begin with, to illustrate this basic cycle, we're going to do a shopping basket example. And we've got a requirement that we need to be able to total all the items in our basket. Now, if we're doing test-driven development, we don't start by declaring a shopping basket class and a method for totaling and then write tests for that. We do it the other way around. So we start by writing a test. So I'm going to create a test fixture. I'm going to be using JUnit 4. A test fixture, let's call it, I don't know, shopping basket test. It is good to name your test fixture so it is obvious what these are the tests for. Okay, so there's our test fixture. And I'm going to start with the simplest example of a shopping basket total that I can think of. So we start with the simplest test case we can think of. So let's write a test method. And let's give it a name that describes what the test is. So total of, well, the simplest example I can think of is an empty basket, which should have a total of 0. So let's total our empty basket. Okay, now we're going to need a shopping basket. And this is how TDD works. We don't declare the shopping basket class and then write a test with it. We write a test that uses a shopping basket class, and that forces us to then declare it so that we can get our test to compile and run. So this is the essence of TDD. This is a big part of it. As we're writing our test, we're making design decisions, just a few in each test. We're making design decisions, and that forces us then to write the code that the test requires. So the test is telling me, you need this class shopping basket. You'll see how, let's put that in the source folder. That's a good idea. You'll see how my IDE, IntelliJ, is kind of geared up for working backwards in this way. So there's lots of little shortcuts, your Alt-Enter key if you're on Windows, for example, that can get you from the use of something to its declaration very, very easily. So let's just... Okay, and what we're saying is that this is an empty basket. So how will we... Well, one way to denote that in our test is to not give it any items at all. So we don't need to do anything yet at this particular moment. And now we've got our empty basket. We're going to assert that the total is 0. So again, we don't declare a getter for getting the total. We use the getter in our test, and that forces us to declare it. The clue is in the name. Let's just import that. The clue is very much in the name. Test-driven development. So the tests are driving what code do we need to write in order to pass this test. Let's create that. That's fine. We will need to return something. Now, I'm going to do something here, and I'm not going to dwell too much on why I'm doing this, but you'll see in a minute what this is for. I'm not going to return 0 because that will pass. Let's just run the test. We'll discuss this in the next video, but I'm just going to run the test and see that the test does fail. So any second now. So my ID has a little think. Okay, so there's our test assertion failing. We'll discuss why it's important to do that in the next video. And then what we do is we just do the simplest thing we can think of that will pass this test, which in this case is not to calculate a total of items in a list, but just to return 0. That's the easiest thing I can think of doing. We rerun our test. And there we are, 1 passing test. Now, of course, that only works for empty baskets, so we're not done yet. I can think of more test cases that will fail. So let's write another test. How about just a single item? So I'm being very clear in the names of my tests here what this test is. What is this test about? Let's again use our shopping basket. So people say about writing test code, well, it's a lot of extra code, but if you're using a modern editor or IDE, often once you've declared something, it will start to fill in the gaps. So there's a lot less typing involved. Now this time our basket isn't empty, so what I'm going to do is I'm going to give it a list of items. We could do it this way, would be easy. A list of items, and we just need one new item. Let's give it a unit price of 100 and a quantity of 1, a single item. And again, we're working backwards from the test here. Let's create that class in our source folder. And that's the unit price. That's the quantity. Okay. And okay, we don't want to do that. Interesting that it decided to do that. Okay, and now let's declare our constructor because the test requires it. So this is the golden rule of test-driven development, of TDD. We don't write any source code unless we have a test that requires it. There we go. There's our shopping basket with 1 item. And again, we're going to assert that this time the total is going to be 100. So at this stage, a lot less typing involved. And we also need to specify in JUnit for doubles, specify a delta to say it has to be exactly the same. And okay, it doesn't like, aha, so we need to pass something in here. So let's just, that should do it. Let's try again. Okay, again, failing test there. And as before, what's the simplest thing I can think of? Well, if our basket is empty, not our basket, our items, and let's just quickly assign that to a field. Otherwise, well, we'll just return the unit price of the first item. So this is telling me now that we need a getter for the unit price. Again, working backwards from the test. Okay. And let's return. Well, at this point we can just return 0. It doesn't really matter. Just going to run the test and make sure that it does indeed fail. Okay, yep, lovely. Okay, now let's start filling in these gaps. There we go. 2 passing tests. Okay, now remember, it's not just about writing failing tests, writing code to pass the tests. We also need to be thinking a little bit about refactoring the code if necessary. So let's do a little code review at this point. Now these 2 tests, they look pretty similar. There's some duplication going on here that I think could be removed. But I'm not too worried about it at this point. It's only 2 examples. So I'm going to leave it for now. Again, we'll explain in a later video we'll talk about removing duplication from code. But at this point, I don't think it's a major problem. In terms of our shopping basket, I'm not sure we could really make that much simpler. In terms of the item, again, I don't think we can make that any simpler or easier to understand. So I think we're good for now. I think we can at this point go on and write a 3rd test. Now let's imagine there's more than one item now. So again, our shopping basket needs to be created. Oops. And this time we're going to give it 2 items. So let's create one with 100 and a quantity of 1. And let's do another one and with a unit price of 200 just for jolly, and a quantity of 1. And now let's assert that our total this time should be 300. Okay, and a delta of 0. Let's run that test, see what happens. Excellent. So now let's do the simplest thing I can think of to pass. Well, we want to pass all 3 of these tests. So we can probably use streams here. Let's map to a double. So our items unit price. And then we can very easily sum that. And we probably want to return in there. Okay. Easy peasy. So it's going pretty well so far. I'm quite happy with shopping basket. I think it's pretty simple for what it is. Item again, we haven't made any changes to that. Now let's take a look at these tests. There's one thing that's bugging me a little now, which is we're reproducing the knowledge of how to create the shopping basket. And if we do that many, many times in lots and lots of tests, the risk is then when we want to change, for example, change that constructor, we have to change it in multiple places. So there is a bit of a risk here with some duplicate code because we're duplicating a dependency between the test code and the class under test that maybe we shouldn't. So what I'm going to do, if I just take a look at that, let's use this one as an example, is I'm going to extract a shared factory method for building shopping baskets. So I think builder is probably a better word for it. So let's extract a method for this. Can't perform new shopping array. Come on. How many? Is it all of them? Yeah, I think it is all of them. So let's take that expression and let's call it, I don't know, build basket with items. So when you're extracting methods to help with the setup, shared setups, it's very, very important to maintain the readability of the test code so that people don't have to look inside that method to understand what it does. So the names of these builder methods or these creation methods, these shared setup methods, should make it very obvious what these methods do so that people don't have to then go jumping around the code to find out. So build basket with items, I hope, is descriptive enough. Let's refactor that. Okay, and immediately I'm going to run my tests to make sure I haven't broken anything. And I think what we're going to do with this refactoring here is, just to make it nice and neat, is we'll just pass in the items we want to build it in as an array of optional parameters there. And that will have made no difference because it's optional. Okay, but now what we can do is just insert our items and replace that there. And now we can reuse this method build basket with items. Well, just an empty array will return a basket with an empty basket. Let's just check that's worked. So you'll notice with this refactoring, I just take one small step and then I get back to seeing if my test pass as quickly as possible. The test is really very helpful here. And finally, this one here. Okay, and now let's move this out of the way. And again, even for something as small as that, I would rerun my tests. So what I've done there, hopefully, is remove some duplicated knowledge of how to create shopping baskets. And this decouples my test code a bit more from the APIs of the classes that it's testing. And that is for, if we're only talking one or two tests, that's not a problem. But as we get more and more tests that repeat that knowledge, then the danger is that our test code becomes too tightly coupled to the interfaces of the code that we're testing. So solve the little problem there. Okay, I'm good to go, I think, for my next test. Let's see what happens when we have a quantity of more than one. Total of item with quantity 2. And again, our IDE is going to help us here by filling in lots of the gaps. Oh, no, we've got a method we can use now. So one of the things that makes it a little useful when we're removing duplication from test code is often it makes subsequent tests easier to write. So we only need one item here. And that's often a good test of whether the refactoring you've done is actually useful. Does it make the next test or the test after that easier? So again, price of 100, but this time a quantity of 2. And now we're going to check that we get double the unit price. And there's the delta. Oops, spelling mistake in my test there. Okay, another failing test. And passing this test is very, very simple. We're just going to get the quantity. So again, we're working backwards here. It's telling us you're going to need to be able to do this in order to pass this test. Okay, and well, let's just assign that to a field. And if we rerun that test, hopefully now it will pass. So we're back with a passing test, and time again to think about refactoring. I think our test code is probably okay. But what about this code here? Well, there's something that's bugging me a little here with this little expression. This is an example of what they call feature envy. In other words, the get total method in shopping basket has envy for the features of item. Arguably, this little expression here is in the wrong class. What we've got here is an unencapsulated item. Shopping basket knows too much about it. So what we're going to do to fix this is we're going to extract this into its own method. Let's call this, I don't know, something like subtotal. And let's immediately run our tests. And then I'm going to move this method to the item class. There we go. So now item is actually doing the work, and this is generally a good pattern for design. Put the work where the data is. So if you're calculating unit price times quantity, then whoever knows that information should really be doing the work. And it also means that these getters here for unit price and quantity are no longer required because nobody else is referencing them. So what I'm going to do is I'm going to inline these and remove the declarations. Let's run our tests. And again with quantity, there we go. So there you go. Now the item calculates the subtotal. The shopping basket calculates the sum of all those subtotals. Our tests cover a bunch of cases. So if we were to break this code here or break this code here, then I've got a high confidence that one of my tests would fail. So going forward, these are going to make good regression tests. And I'm also happy with the design of this code. I think it is easy to understand. There's not much in the way of duplication in there. We fixed a little problem with dependencies. We've hidden some stuff about the item from shopping basket. So I'm okay with this. I think we can leave this. So there you go. That's the basic cycle of test-driven development. You start by writing a failing test. You write the simplest code to pass that test that you can think of. And then very importantly, you stop and you review the code that you've written or that you've changed. And if necessary, you refactor it to make it easier to change going forward. Now, in upcoming videos, we're going to be looking at more advanced topics relating to TDD, particularly in the next one where we're going to look at some good habits, some of which, at least one of which you've seen me doing, and I'll explain why I've been doing it in video number 2.